So to prove that dx dy is going to be equal to 1 over dy dx, we are going to introduce the f of inverse of x. So say that there is this function y is equal to f of x. We apply this inverse sign on both ends, but on both sides we have f inverse of y is equal to f inverse of f of x. And we know that this part is going to be x, so we have f of inverse of y is equal to x. All right, great. So this is the original function, and this is the inverse function. And let's look at this inverse function of f of x. For this, we want to differentiate both sides with respect to x first. So we apply this differentiate rule. We apply this differentiate sign on both sides. We have dx, d f of inverse of y, dx, dx, right? And for the right hand side, it's going to be equal to 1. And for the left hand side, we are going to use the chain rule. So we have f inverse of y primed times dy dx is going to be equal to 1. And still for this inverse function x is equal to f inverse of y, this thing, we want to differentiate both sides with respect to y. So we write something like this. Is equal to dx dy. And for this right hand side, it's going to be dx dy, and for the left hand side, it's going to be f inverse of y primed times, we are still using chain rule here, dy dy is dx dy. And we know that dy dy is 1, so we have f inverse of y primed is dx dy. So let's assume this is 1 and this is 2. So we want to plug 2 into 1. So we have dx dy times dy dx is equal to 1. And we can use an example to illustrate this a little bit, I believe. So say that there is this function y is equal to x cubed, right? And actually, we don't have to use the inverse function of it. We just we want to differentiate both sides with respect to x and y, respectively. Let's start with this differentiating both sides with respect to x. So we have dy dx is going to be equal to 3x squared, right? And then we want to still differentiate this y is equal to x squared with respect to y. So we have dy and dx cubed dy. And this dy dy is going to be equal to 1, so it is going to be equal to 1 is equal to 3x squared dx dy. Now let's look at these two, 1 and 2. So is it perfectly clear that 1 is going to be equal to dy dx times dx dy? Of course, you can use the inverse function to demonstrate it too. All right, so we know that dx dy is going to be equal to 1 over dy dx.